Now coming to the aggregates. Aggregates are broadly classified into two: fine aggregate and coarse aggregate. They are classified on the basis of their size. If the particle size is between 0.075 mm and 4.75 mm, then you call such a particle or soil or aggregate as fine aggregate. Generally, the river sand is a fine aggregate. These days, the mining of river sand is prohibited. In such cases, you manufacture what is known as manufactured sand or M sand. Coarse aggregates are those with particles having size greater than 4.75 mm. Generally, the hard blasted granite metal chips are of size greater than 4.75 mm. And there is a codal recommendation based on Indian standard codes. There is a maximum size to which you can use an aggregate in a structural member. If you want to construct a concrete slab of a definite size, let us take the thickness of the slab as 10 centimeter. Then based on the standard recommendation, the maximum size of aggregate is not expected to be exceeding 1/4 the minimum thickness of the member. In our case, the thickness of the slab is 10 centimeter. Then the maximum size of aggregate should be less than 1/4 times 10 centimeter, which is equal to 2.5 centimeter or 25 millimeter. Hence, you can use a maximum size of aggregate as 25 millimeter if you want to construct a slab of thickness 10 centimeter. There are other codal provisions written here. In case of heavily reinforced section, the maximum size of aggregate should be the smaller of the clear distance between reinforcing bars minus 5 millimeter or the minimum cover to the reinforcements minus 5 millimeter. Now let's discuss about grading of aggregates. Grading is nothing but the particle size distribution of the given aggregate sample. If you have a sample of aggregate, you are determining what all sizes of aggregate is present in that sample and also how much quantity of each size is present in that sample. And if you want to find this out, you have to perform what is known as sieve analysis. And by performing this, you will get what all sizes are present in your aggregate sample and of how much quantity also. And then it is possible to plot a curve as shown here. So once you perform sieve analysis, you get the details of sieve sizes on which these aggregates get retained and also how much percentage passes through each sieve. This can be found out from this test sieve analysis. And your aggregate will have a grading curve as any one of these four curves shown here. It may be 1, it may resemble 2, or it may resemble 3 or 4. If your aggregate grading curve resembles 1, then it represents that your aggregate contains more coarser material, or it is said to be coarsest grading curve. Curve 1 is known as coarsest grading curve, or your aggregate contains large particles in more quantities. And if your aggregate sample gives a grading curve as shown here as curve 4, if it resembles 4, then it contains more finer particles. So that is how you can differentiate what kind of aggregate sample you have with you. So which one do you think is better, having a coarse grading or a fine grading? Effectively, as we already discussed, you need all range of particles. The aggregates should not be very large in size, and it should not be always very small in size. You need all range of particles, not just one kind of particle, because having all ranges of sizes will result in better filling of voids, and it helps to make the concrete more denser. So that is very, very beneficial for concrete. So such a set of aggregates, such a sample of aggregate in which you have all the ranges of aggregates in definite proportion, somewhat resembling curve 2 or somewhat resembling curve 3, is better, or somewhere in between 2 and 3, or somewhere between 1 and 3 is always better. You cannot say that the aggregates used in concrete should be of a particular size. No, you should have all continuous range of sizes so that the voids in your concrete mass get eliminated thoroughly. Now, such a aggregate in which you have proper grading or proper range of samples of definite sizes in definite proportion, you call it well graded aggregate. So well grading of aggregate is a very important requirement of concrete. Now, having a well graded aggregate can result in so desirable properties of concrete. It can affect the properties of concrete, about which we shall have a discussion briefly. A grading of aggregate can affect the workability of fresh concrete and also the degree of compaction. What is workability? The workability is the ease with which you can mix, place, compact and finish a concrete mix. So the easiness with which you can work with concrete is represented by what is known as workability, and a good grading shall result in better workability of the concrete. Same is the case of compaction. Compaction, you do compaction of concrete in order to eliminate the air bubbles or air voids present in concrete. So for better compaction, for the easiness with which you can perform compaction, you need good grading. Okay. Now, there is a great importance of grading with respect to the strength of concrete also. A good grading or well graded aggregates can result in better density of concrete and also hence result in better increased compressive strength of concrete. So a well graded aggregate shall result in good compressive strength of concrete also. Then what about the presence of more fines in concrete? By fines I mean cement and sand, which are the finer particles in concrete. Presence of more fines is also beneficial to concrete to a greater extent. It will help to improve the workability of concrete. It will help to resist segregation also.